The last differentiation rule we're going to look at is the quotient rule. And I like to think of the quotient rule as an optional differentiation rule. You can actually get by without it, but sometimes it really makes life a lot nicer. So for this problem, we're going to do it using the quotient rule, and then I'm also going to do it using the product rule and the chain rule to show you that you actually don't need the quotient rule. So here we have a function, y equals x squared plus 7 all over 5x minus 1. And we use a quotient rule when we've got a function in the form where there's one function of x on the top of a fraction and another function of x on the bottom, so u over v. And this is what the quotient rule tells us. It tells us that the derivative, dy dx, is given by u dash, so the derivative of u, the function on the top, times v minus v dash times u all over v squared. And we write it like this because it has a very similar form to the product rule from before. The product rule was u dash v plus v dash u. Here we've got the same thing on the top, or in fact I wrote it around the other way before, u v dash for the product rule. Looks exactly the same, but it's just a minus sign in between. And it's really important with the quotient rule that you get the order here correct. You can't just swap and do the v differentiated first and the u differentiated second. If you make that mistake with the product rule, it doesn't matter because we know the order of in which you add things doesn't matter. But with subtraction, it does matter what order these two are in. So make sure you get the order right here. I like to remember that u comes before v in the alphabet, so I have to differentiate u before I differentiate v. And the quotient rule, of course, also has this little v squared on the bottom here. So let's have a look here. I've got x squared plus 7 is my u, my 5x minus 1 is my v, and I can just go ahead straight away and differentiate using this rule. I've got to differentiate my u, so the derivative of this bit has to be 2x multiplied by v unchanged. Take away u, this top part, multiplied by derivative of v. Derivative of v, of course, is just going to be 5. And that's all over v squared. And v is 5x minus 1, so I have a 5x minus 1 all squared on the bottom. Let's expand this. 2x times 5x is 10x squared. 2x times minus 1 is negative 2x. Tidying this up, I get minus 5x squared plus, minus 35, because that negative sign has to apply to everything inside. And that's all over 5x minus 1 squared. Looking on the top, 10x squared minus 5x squared is 5x squared minus 2x minus 35 all over 5x minus 1 all squared. And so that's how we differentiate this function using the quotient